We would actually be starting to build stuff, but we don't have enough materials. What we can do is talk about some of the math behind figuring out which resistor we need, and also what the bands on the resistors mean. Because each resistor, and I will get one out here and switch the cameras and show you one of the resistors. So let's go ahead and go to this one. We'll pull it back out again. Get it set up right. So when I talk about the bands on a resistor, you should see 4 colors. I'm seeing orange, almost a blacky purple, and a green. And yeah, that's all we've got. So that determines what this can take. And the best way to work with it just pull up the resistor color guide. And let's see. Okay, here thought I had that on there. Okay, hang on. And here we go. So this is from resistorguide.com. So looking at, and we have our colors listed on the left with a really dumb acronym to help one remember. But we don't need that because we've got the chart here in front of us. So we are looking at, and we get it turned right, because there is what looks like a gold band, but I might be wrong. Anyway, we've got a orange, which is going to be in the first position. So that's going to be a we're looking at a 3-band with orange, this black or is it violet? I'm going to go with black. And green. So if we have this, we know that we have a orange in the first, so that's going to be a 3, and we can multiply that by 1k, so that's going to be a 3k. We have a black, so that's going to be a 0. Okay, and a green, which is going to be a 500k. So that is going to be well, may not have done this quite right because we add them all up. Let's see. Anyway, I know the value because it was printed on the package. They're 3 million. So we will just go with that. And I will figure out what is wrong with my figuring later. But we don't need to be that concerned with the bands. What we need to be concerned with is figuring out how to, one, get the resistance value for our circuit, and two, diagram out our circuit. So for that, we're going to be having a circuit that looks something like this. And I know this isn't an actual circuit, but I work better this way. Got our 9-volt battery. It's 2 terminals. And I know you can't see this. I will hold it up as soon as I get it finished. So we've got the cap that goes over the 2 terminals, and one cable is, or one wire coming out goes up to the switch, and then into our breadboard, then crosses over to our LED setup. From that we go to the resistor. The other end of the resistor goes back up to the other end of the wire for our battery. So here's what we've got. 9-volt battery, one leads up to a switch, which leads into the breadboard, which then connects to the LED, connecting to the resistor at the bottom, and wire leads all the way back up to the other host of the battery. So now that we've got our diagram, we need to figure out what value that resistor needs to be. And to do that, we're going to use the formula R equals Vs minus Vf over I. And these stand for I is the LED forward current, Vf is the voltage drop for the LED in volts, and then Vs is the supply voltage. So right away we know R equals (9) minus Vf over I. Now, to get Vf and I, we look at the data sheet for our LED, and the one I have has I, and this was pulled from the internet. I'm gonna double check these at the store again. Kind of thinking they didn't put the information right on the internet, but that happens. So we've got 9 minus Vf, which is 1.1993. Let's see. Let's see, 1993. It said there were that was the value for one of the modules. So we have 4. Let's just do some quick math. So that would be for 4.7972. I will go with that. So we had 9 minus 4.7972. And then the I value for 1 is 0.08880. If we multiply that by 4, we'll save you the pain of waiting for me to do it manually here, because I figure you just want to get to the results as well. Still buffering issues, huh? Well, sadly not much that can be done about that. Everything looks like it's doing fine on my end. So now we have our variables all filled out. Just some quick calculator math here. It's going to be 9 minus 4 1972 gives 4.2028. Over 0.3552. Gives us a rating of 11.83. That tells us the value of resistor that we are going to need. And we just so happen to have that value of resistor. But as I was saying, we don't have an actual working setup yet, so we will get there. But that is, I'll lift it up so you can see the math. Probably like it turned around. So there's the math I did to get to our value of resistor. And that is pretty much going to be it for this crafting session. Let's go back to the, oh, wrong one. There we go. So that's going to be it for this crafting session video. I hope you enjoyed watching my slightly failed attempt at math. It's been a while, I do admit that. Until the next one. That's all for this session of Polygonal Art with JoRaSe's. If you enjoyed what you saw, how about giving this video a thumbs up? And don't forget to subscribe so you won't miss out on future videos from me. In the video description below, you'll find my Patreon link. Feel free to check it out. Now, on to the credits.